In this video, I want to go through how to use dimensional analysis when we have nonlinear units. So if you look at the paper here, very specifically I'm talking about when our superscripts are squared or cubic units. The thing is, the metric scale as we've learned it is a number line, and that's a linear thing. So when we do things from metric like moving the decimal, we're really making a linear conversion and just moving along that line. If we're doing squared terms like for area or cubic terms like for volume, the unit's actually changing in multiple dimensions at once. So moving along a line doesn't take care of but part of the unit conversion. So we really need to do dimensional analysis to make extra dimensional conversions. So let me just show you here through a few examples of how this would work. In the first example, we have 0.5 meters squared. And we're going to set it up just like a normal problem, like we've been doing in class. We put the meter squared on bottom, and we're looking for millimeters squared. Okay, so now is the twist. We're going to put in our numbers like normal. So meter is larger. There are 3 steps that separate milli from meter. And the real twist, here we go. We have to do the same function to the numbers that we did to the units. You see here our units are squared. So I need to square the numbers in the conversion factor. After I do that, we get 0.5 times 10 to the 6. Remember, when you take a power to a power, you multiply the numbers, and the unit is now millimeters squared. The conversion is over, but if we want proper scientific notation, we'll go right 1 and take away 1. So that's going to be 5 times 10 to the 5th millimeters squared. Okay, let's do that again so you'll get used to squaring or cubing those numbers. In the next problem, we have 4.7 centimeters squared, and we're going to convert that to kilometers squared. So this problem is also squared, so it's going to look very similar. So we have to put 1 next to the larger unit, and let's count our steps. Take a moment. How many steps separate those two? Think about it. There are 5 steps that separate them, so 10 to the 5th. And now we have to do the same function to the numbers. So if this is squared units, I need to square my numbers. Now for the math on this one, the 10 to the 5th squared is going to be in the bottom. So that's going to be 10 to the 10th in the bottom. Our final answer, as we bring that out of the denominator, gives me 10 to the minus 10 kilometers squared. All right, I hope you're starting to see how this works. Let's do number 3, because in number 3, we don't have square units, we have cube units. We want to convert from cubic decimeters, so we put it in the bottom, into cubic millimeters. Put that in the top. Let's fill the numbers in. Decimals are larger. And there are 2 steps between those two, only 2. But now we need to do the same function to the numbers. So with cube units, I cube the numbers. So we're going to cube this here. This conversion then is 5 times 10 to the 6th millimeters cubed. All right, I want you to try number 4 now. So hit pause in the video, try number 4, and I'll post the answer. Okay, so here is almost the final answer for number 4. If you did the conversion correctly, you got 1,000 times 10 to the 6th, and then we're going to fix that by moving the decimal 3 places to the left, and that'll give us 1 times 10 to the 9th centimeters cubed. All right, now in number 5, we don't have metric anymore, so let's try doing this in the English system of units. It's going to work exactly the same way, but it'll actually be a little tidier. I think you'll like the way it looks more because we don't have those steps to worry about. So inches squared, as normal, goes in the bottom. We're looking for feet squared, put that in the top. We put the numbers in as normal. In 1 foot, there are 12 inches. And now here again, extra dimensional, so it's different. We need to do the same thing to the numbers. So 1 squared, 12 squared. Square the numbers to match the units. So for this problem, we're actually going to be dividing 356 by 144. So get the calculator out, do that, and you get 2.47 square feet. And then finally, in number 6, we have multiple units. So we have 46.87 pounds per cubic foot. And we're going to convert that into grams per cubic centimeter. Let's take care of the grams first. So we'll put pounds on bottom, grams on top. Here's a conversion factor that I'm not sure you have on our list from class. There are 454 grams in a pound, so that takes care of that. Now we just need to convert the cubic feet into cubic centimeters. So let's set up a conversion to get rid of the cubic feet. We'll put that in the top. And since I don't have a foot to centimeter conversion, let's go to inches first. So let's do cubic inches. So 1 foot is 12 inches, but we need to cube the numbers to match the units. Okay, that gets rid of the cubic foot. Now that I'm in cubic inches, I want to go to centimeters cubed. So let's put inches cubed on top here, and we'll put centimeters cubed in the bottom. In every inch, there are 2.54 centimeters, and since the units are cubed, we have to cube the numbers. So we have a bit of a complex set of math here. Follow along in your calculator. Hit pause if you need to grab it. I'm going to type in 46.87 times 454, and then I'm going to hit divide by 12 cubed, and then divide by 2.54 cubed. And that comes out to be 0.751 grams per centimeter cubed. All right, so if you have any questions about that, come by and we'll do some more together until you fully understand.